All right, ladies and gentlemen, today we're going to talk about solving linear equations and inequalities, so section 2.1. All right, so we're going to talk about solving equations, solving inequalities, some of the more basic equations and inequalities today. Should be a lot of review from Algebra 1, hopefully.
I heard Algebra 2 is easy.
So the first thing we're going to talk about today is an equation. An equation is a mathematical statement that two expressions are equivalent. What is the main difference between an equation and an algebraic expression? What does an equation have that an algebraic expression does not?
Numbers. Letters.
What does equivalent mean?
Equal to.
So what's the big thing that an equation has that an expression does not?
Answer.
Equals. An equation will have an equal sign. Okay, and we're talking about equations. Now we're talking about something that is equal. Equations means two expressions are equivalent. Solution set of an equation is the set of values that make an equation true. For instance, if I had the equation here, x plus 4 equals 7, what's the solution of that equation? X equals 3. That would be the solution of that equation. Okay, x equals 3. Linear equation in one variable. A linear equation is an equation that can be written in the form ax equals b, where a and b are constants and a does not equal 0. Essentially, a linear equation just means that you have a linear x. So you have a singular x there. Okay. Identity. We're going to talk about this a lot today. Okay, this is probably about really the only newish part for you. Identity is an equation that is true for all values of the variables. Identity means that we're going to get something that is like all solutions. Okay, identity is something that would mean all solutions. Okay, so notice here I get a true statement. 3 equals 3. Is that a true statement? Yeah, 3 equals 3. That is an example of something that is all solutions. 3 equals 3. All right, next I have what's called a contradiction. A contradiction is an equation that has no solutions. Again, something that has no solutions. This would be like if I had a false statement. For instance, 1 equals 0. 1 equals 0. Is that a true statement? No. 1 does not equal 0. False statement. Henceforth, I get no solutions. What do you notice about both of those? Do they have any x's at all? No. My x's canceled out. So when my x's cancel out, if it's a true statement, I get all solutions. If it's a false statement, I'm going to get no solutions. And the last thing I have is inequality. Inequality is a statement that compares two expressions by using the less than, greater than, less than or equal to, greater than or equal to, or not equal to. For example, let's say I have x is greater than negative 2. If my statement is x is greater than negative 2, is negative 2 my answer?
No.
No. What could be my answer, though?
X.
Positive what? Positive 2. Is positive 2 greater than negative 2? Yeah. So inequalities, make sure you notice now, we're not talking about the actual number here. Now we're talking about something that's actually less than or greater than, less than or equal to, greater than or equal to, etc. So let's look at number 1 here. I have 6x plus 3 minus 8x equals 13. What do you notice about my x's? Are they on the same side here? And when they're on the same side, can I combine them, Allie? When I combine them, do I take the sign in front of or the sign behind? In front of. So I have positive 6x minus 8x. Well, that's going to give me negative 2x plus 3 equals 13. Okay, now I want to solve this. What would be my next step, Allie? Subtract the 3. So I get negative 2x equals 10. Next I would, what do I do? Divide by negative 2. And I get x equals a negative 5. Same thing on number 2 here. 8x minus 5x. 8x minus 5x gets me 3x minus 21 equals negative 15. Now I would do what, McCoolidge, next? Add the 21 over. So I get 3x equals 6. Divide both sides by 3, and I get x equals what, McCoolidge? X equals 2. Nice job. Okay, next here. Notice I have parentheses here. When I have parentheses, what's something I have to remember to always do? Distribute. On a problem like number 3, what am I really distributing here, Katie? A negative of what? Yeah, I'm distributing that negative or negative 1 really. So when I distribute it, I'm really going to get an equation that says 9 equals 6 minus x minus 2. So 9 equals 6 minus x minus 2. Now I can combine like terms. I can combine 6 and negative 2. So I get 9 equals 4 minus x. Oh, I want to solve for x here. What would be my next step, Beast? Subtract 4. So I have 5 equals negative x. What's my last step here going to be to do? No, I can leave my x over there. Divide by? Divide by the negative 1. So there's that negative out in front. I want to divide by negative 1. Give me an answer of x equals negative 5. Okay. Hannah, what do I want to do on number 4 first? Yep, what's that called? Yep, distribute that 4. So I get 4x minus 8 plus 2x equals 40. What's 4x plus 2x going to get me? Anybody? So I have 6x minus 8 equals 40. Next step would be to add 8. 6x equals 48. Divide by 6. And x comes out to equal 8. Nice job. All right. Next here, I have variables now on both sides. What do you notice I have to do when I have variables on both sides? I have to move the variable, right? Now, I always suggest to move the variable so the variable stays positive. Now again, you can go either way, but I always like to move it so the variable stays positive. Just makes less mistakes at the end. So for instance here in 5, I would subtract 4k to the left here. Why? Well, 7k is larger, telling me that I'm going to end up with a positive variable. So I have 3k equals 15. Divide both sides by 3. I get k equals 5. Now in 6, same thing here. I can move either x. Which one would you suggest moving though, Joe Daniels? Why? Yeah, it's smaller. It's going to ensure that I have a positive variable. So I get 2x minus 2 equals 4. Add the 2. 2x equals 6. Divide both sides by 2. I get x equals 3. All right. Take a couple seconds to try these two on your own. All right, if we look at number 7, what would be the first thing you want to do, Drew?
Distribute.
Distribute. So you get 2y plus 12 equals 3y. Then what would you do, Drew?
Subtract 2.
And you end up with an answer of y equals 12. Number 8, what do I want to do first, Crump?
You want to distribute. Right?
So I get 2k minus 5 equals 3 minus 6k. What would you do next?
Add the 6 to the 2.
Add the 6k over. Good work.
And you'll subtract the 3 to get 8k equals negative 8.
I want to add the 5 to the other side.
Well, yeah. I mean, I did it.
So I have 8k equals 8. Now divide both sides by 8. And I get k equals
1.
positive 1. There you go. Next part we're going to talk about here. Well, let's look at number 9 here. A negative 5x plus 4 equals 6 minus 5x minus 2. Can I combine the 6 and the negative 2 there? Yeah, I can combine those. So I get negative 5x plus 4 equals 4 minus 5x. Okay? Now, equations, we're always going to move variables the same side, right? So what I want to do here, I'd want to add 5x to both sides. Okay, no problem. Add 5x to both sides. What happens though? My x's cancel out. I'm left with 4 equals 4. Is that a true statement? That is a true statement. So that means my answer is going to be then all solutions. Okay? If my variables cancel out, that means it's going to tell me whether the answer is all solutions or no solutions. If it is a true statement, notice this is a true statement, that's when I get all solutions. Let's look at number 10 here. Can I combine negative 8x and a positive 9x? Yeah, they're on the same side, so I get x plus 6 equals negative 17 plus x. I'd want to subtract x on both sides, right? So I subtract x. And I get 6 equals a negative 17. True statement or false statement? That is a false statement, so now my answer is going to be no solution. Again, that's kind of the toughest part about today, is what happens when your variables eliminate. False statement, no solution. True statement, all solutions. All right, that's the toughest part for you guys today, is identifying those. Take a couple seconds, try these two on your own. Same idea. So let's look at number 11 here. I would combine the y's on my left side. So that'd give me 3y plus 7 equals 10 plus 3y. You end up with something that says 7 equals 10. What's that going to mean, McCoolidge? That is no solution because that is a false statement, correct? Good. Number 12, I would combine the c's on the left side. So I get 3c plus 7 equals, I'd combine my constants on my right side. 7 plus 3c. Subtract 3c to both sides. And I end up with 7 equals 7. True or false statement? True statement. No solutions or all solutions? All solutions. Nice job. And the very last thing we're going to talk about today is inequalities. What's the one difference between inequalities and equations? What's one of the main differences between inequalities and equations? When you solve them, what's the one thing you have to remember to do? If you do something to both sides, you got to do what? What happens if you multiply and divide both sides by negative? You got to flip the sign. That's about the one difference in solving these equations. Otherwise, you solve them the exact same. For instance, 13 here. I'd start off by subtracting 7. I get 6a is greater than 12. Divide by 6, and I end up with a is greater than 2. Does that mean 2 is my answer? No. What could be an answer here, though? What'd you say? 3. Could 10 be an answer? Could 2.5 be an answer? Could 2.00001 be an answer? Yes. Could 1.9 be an answer? No. It has to be greater than 2. So recognize, like on multiple choice tests, a lot of people always want to put 2 as an answer on a question like this. No. Yes, you do get x is greater than 2, but let's talk about inequality now. So what's the number that's actually greater than 2? Well, 3, 4, 5, 6, something like that. Same thing on 14 here. I'd want to solve. First thing I want to do is add 4 to both sides. I get negative 3x is less than or equal to 18. Divide both sides by negative 3. What do I have to remember to do now when I divide both sides by negative 3? What do I have to do? Flip the sign. So now my answer is x is greater than or equal to negative 6. Again, notice I flipped the inequality symbol because I multiplied or divided both sides by a negative.
So when you multiply by
Both sides by a negative. Notice I divide,
what if it's by plus?
like on number 13, notice on number 13,
Oh.
there's positive, so I did not flip the sign. It's only when it's negative do you flip the sign. Okay, take a couple seconds to try these two on your own. Katie, you walk me through how you did number 15.
I subtracted 8.
Okay, so we subtracted 8, nice job.
Then I got 2x greater than 4 and divided by 2. Got x greater than 2.
So give me a possible solution here. So 3, very good. So x is greater than 2, so 3 is a possible answer here. 3.5 is a possible answer here, nice job. 16, walk me through what you did here. Joe Daniels, what'd you get? Or what'd you do?
I subtract 13 on both sides.
Okay, so we start off by subtracting 13. Negative 3x is less than or equal to 12. What'd you do next?
I divide by 3.
By negative 3, right? Now what do you have to remember to do when you divide by negative 3?
Flip the sign.
So I get x is greater than or equal to negative 4, right? Now, would negative 4 be a solution here, Joe?
Yes, sir.
Why is negative 4 a solution now?
Plus, I don't know, it's greater
Yes, greater than or equal to. That equal to means now it can be part of the solution. Nice job.